Hello everyone. In this video we're going to demonstrate how to configure some routing redundancy using the hot standby router protocol, which is also known as HSRP for short. We will utilize a single network of 192.168.1.0/24, to which we're going to add 3 nodes, a cluster of 2 routers and a PC that will act as our tester. So without further ado, I am going to create 2 routers very quickly, which I am going to rename to router 1 and router 2. So router 1 will have the IP address of 192.168.1.2, whereas router 2 will have the IP address of 192.168.1.3. The .1 IP address is going to be the virtual IP address presented by our cluster to the client, which is going to be this PC here. We shall connect all of our devices to the router, to the switch, sorry, like so. And we will enter the CLI of router 1. So I'm going to run no enable conft interface gigabit ethernet 0/0/0 IP address 192.168.1.2 with a subnet mask of 255.255.255.0. Then I'll run standby 1 IP 192.168.1.1, which is the virtual IP address of our cluster. We shall assign it a priority level of 110, and we will run standby 1 preempt, which means that this router will automatically take control if it comes online and it has the highest priority. Finally, no shutdown, and then do wr-mem to save the changes. We'll close that window, open up the second router, go into its CLI, enable conft interface gigabit ethernet 0/0/0 IP address 192.168.1.3 255.255.255.0 is going to be its subnet mask. Next, standby 1 IP, same as before, 192.168.1.1, which is the virtual IP address. Standby 1 priority 100, and then finally standby 1 preempt. No shutdown, and then do wr-mem to commit the change to memory. We close that window, and we shall give our client an IP address of 192.168.1.10. The default /24 subnet mask is the one we need, and the .1 address is the virtual IP address that is going to be exposed by the hot standby router protocol. Finally, we will fast forward the time to make sure that our changes have taken effect. And next, we will ping the virtual IP address of our router cluster from our PC. So if I run ping 192.168.1.1, we can see that it can reach it without any issues. So in order to verify that we have successfully configured the hot standby router protocol and that the standby node can indeed assume the role of the active one, I will run a continuous ping against the virtual IP address of 192.168.1.1, and while it's doing that, we will simulate a failover by shutting down the interface of the active router. And to confirm which is the active router, if I do show standby brief, we can see that this is the active router. So this is the router that is going to be responding to the PC, whereas the second router is currently the standby one. Okay, so I will go back here and I will initiate a continuous ping of 1000 requests to the virtual IP address. So I'll go back to router 1 and into configuration mode, interface gigabit ethernet 0/0/0 and shut down. And if I go back to my PC, we see that one request gets timed out and another. Why? Because router 1 is currently not responding to this piece ICMP echo requests because we shut down its interface. But you see that on the 4th request we started to get responses back again, but this time from router 2, which should have changed its status from standby to active. So if I run show standby brief, we can see that it's now active, whereas previously it was in standby mode, thereby verifying that we have successfully configured routing redundancy using the hot standby router protocol. Thank you very much for watching.